Hello students, today we will be continuing with chapter 2 and we will move to the third part of this chapter, that is equations of motion. As you can see here, I have written 3 equations. These are the equations of motion. First one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. And third one is V square is equal to U square plus 2AS, where V is the final velocity, U is the initial velocity, A denotes acceleration, T is the time, S is the distance traveled. Okay. Now we will be deriving these equations. These equations can be derived by 2 methods. First is graphical method and the second is the alternative method, that is without using any graph. Okay students, while you drawing the graph, make sure you are making use of pencil only. The HB pencil that you people know, you will be using that. No colors, no pen, nothing is allowed except the pencil. Okay, this is a very important rule that you need to maintain while drawing the graphs. And do the markings on the graphs properly, like which axis is denoting which factors. Like you can see, x-axis is denoting time, and in bracket you write the unit, and y-axis is denoting velocity, and see I have written the unit meter per second. Now we will be starting with the proof. It says, consider the linear motion of a body with an initial velocity u. That means the body has started with a velocity u. The body accelerates uniformly, and in time t it acquires the final velocity v. Means in time t its velocity was v. Now first we will be calculating the acceleration. You know, I have discussed in the previous video that acceleration can be calculated from velocity time graph by calculating its slope. So here we will calculate the slope of the line AB. Initial velocity u is equal to OA at time t equal to 0, and final velocity v is equal to OC at time t. Now A, that is the acceleration, will be the slope of the line AB, that is given by EB by AE. Now EB is equal to OC minus OA, and AE is also equal to OD. Now OC is equal to V, OA is equal to U, and OD is equal to T. Now by cross multiplying we get AT is equal to V minus U, and simultaneously we can show that V is equal to U plus AT. This is our first equation of motion.